All right, hey, Rust versus Go, a hands-on comparison. I hope they take that little gopher and they just squeeze it until its eyes pop out. Anyways, oh no, not another is Rust better than Go article. Seriously? Haven't we all had our fill of these comparisons by now? No, we haven't. We wish for more. Before you sigh in exasperation, hear us out. Many comparisons between Go and Rust emphasize their difference in syntax and the initial learning curve. However, ultimately, what matters is the ease of use for non-trivial projects. Fair. Sort of fair. Is that fair? Okay, so I'd go with the counter take. I would say that what matters is their ease of use for their ideal development domain. Does that make sense? Meaning that if you take Rust and you're like you use Leptos, which is a sweet solid-like framework to be able to do front-end development via Rust, air handling and some things, it's much harder, right? You don't get this instantaneous reload time. It's just a harder thing to do. You get these like 5, 8, 10-second recompiles. And, it's just like I could find myself probably getting pretty frustrated, especially as the project gets larger. Like, I think using Rust for everything is a mistake. Just a thought. Anyways, since we are a platform as a service provider, we think that we can contribute the most by showing you how to build a small web service in both languages. We will use the same task by popular libraries for both languages to come to the solution side by side so you can make up your own mind and get a feel for what it is like to work in each ecosystem. So before you dismiss this is just another comparison, give it a read. Okay? Hey, you give it a watch. Sit down. Put your butts on the seat and listen, or standing desk, or whatever you have. Treadmill desk, hamster wheel, I don't know. There might be some details the other comparisons have missed before. That old Rust versus Go debate. The Rust versus Go is a topic that keeps popping up, and there has been a lot written about it already. This is part because developers are looking for information to help them decide which language to use. Okay, hold on. We're just going to move past that. Let's just get going, okay? We don't need another one, all right? Building a small web service. We'll cover the following: routing, templating, database access, and deployment. Awesome. We will leave out topics like client-side rendering or migrations and focus on server-side only. Perfect. Picking up a task that is representative of web development is not easy. On one hand, by the way, this is also a good time to point out that even if you were to just do this, it's still incomplete because you should also show, like, say, using Go for a very complex CLI tool that, say, involves many different JSON decoding and structures. And how do you do heterogeneous lists? How do you do these kind of things that are much easier, say, in the Rust ecosystem that makes CLI tool development really awesome, but can be a little bit hard in Go? Or how about command line, command line arguments. Command line arguments, like in our heads, those are all simple, but they're actually really hard to make a comprehensive and good set of command line arguments. It's actually very non-trivial. And Rust with clap, call it the baby powder, it's so good. Okay? It's so good it will have you chanting Chirrut by the end. Real talk. All right. So, I mean, is this complete? Is this a complete representation? No, because it's only what is it like to do server-side applications, and ultimately, what is it like to do a simple server-side application? We decided to build a weather forecast service. The user should be able to enter a city name and get the current weather forecast for that city. The service should also show us a list of recently searched cities. Okay. As we extend the service, we should add the following features: a simple UI to display the weather forecast. It better be HTMX. HTMX mentioned. Can someone check that box up there? A database to store recently searched cities. Let's see, the weather API. Oh no, what happened to the, what? It's like hidden text. What is this, Super Mario? What is this, Mario? For the weather forecast, we'll use Open Meteor API because it is open source, easy to use, and offers generous free tier for non-commercial use of up to 10,000 requests per day. We will use these two API endpoints: the geocoding API to get coordinates of a city, the weather forecast API to get the weather forecast for a given coordinates. These libraries for both Go, OMGO, and Rust, Open Meteo, which we would use in a production service. However, for the sake of comparison, we want to see what it takes to make raw dog to HTTP request in both languages and convert the response to an idiomatic data structure. Hell yeah, brother girl. Hold on, let's try. I'm gonna everybody, flashbang warning. Nice, let's go. See, they had these. Look at how cutesy that is. Look at those cutesy links. See, I knew it. Being originally created to simplify building web services, Go had a number of great related packages. The standard library doesn't cover your needs. There are a number of popular third-party web frameworks like Jin, Echo, and Chai. I mean, I use Echo for simple web servers all the time. It's really nice. It's very simple, easy to use. Get in, get out, boom. People seem to love Fiber, though. Echo, easy W. Which one to pick up is a matter of personal preference. Some experienced Go developers prefer to use the standard library and add routing like a library like Chai on top of it. Others prefer a more batteries-included approach and use a full-featured framework like Jin or Echo. Both are fine, but the purpose of this comparison, we choose Jin because it is the most popular. I don't understand their little gradient links. It supports all the features we need. Okay, so if you've never seen it, this looks pretty much straightforward like any other version. You just do a little bit of this, bada bing, bada boom. All right, so this must be making a request. Here's the URL. Here's the response. Get out the body. Do new JSON decoder. Long as we got some results, we return them. Okay, cool. The function takes the city name as an argument and returns the coordinates of the city as a lat-long struct. Note how we handle errors at each step. We check if the HTTP request was successful, and if the response body could be decoded, if the response contains any results. If any of these steps fails, we return an error and abort the function. Yep. So it's a little bit more cumbersome than Go, for sure. The defer statement ensures the response body is closed after the function returns. This is a common pattern in Go. Yes, absolutely, because it doesn't have the drop semantics that Rust has, which is also, again, very useful. Error handling takes up a big part of the code. It's straightforward, but it can be tedious to write, and it can make the code harder to read. I don't necessarily think it makes the code any harder to read. I guess I'm pretty used to seeing that. Maybe once you see it a little bit, it gets easier. Is anybody truly offended by this? Any non-JavaScript devs actually offended by this? Any non-JavaScript devs? Because I know JavaScript devs are always just like, why would I ever handle errors? And it's just like, yo, dog. Sometimes things throw. That's what try catch is for. Where's your try catch? I don't know. I have no idea. What's a try catch? Do these people exist? They do exist. I've noticed that the people that hate most the if error equals nil they just love JavaScript, where they just don't handle any errors, right? You got to remember in JavaScript, every time you JSON parse, you have a potential to throw an error and completely break your control flow. Every time you do the keyword await, you have a chance to break your control flow again with another asynchronous error. Like each one of those spots is a potential like oopsie daisy. People don't really realize that. It just happens. It just happens. Someone's saying, no, in the vibe? In the vibe, are you saying, are you disagreeing in the vibe? Are you disagreeing? Not at all? Okay, hit me. Hit me in the vibe. Hit me. Why is that not true? Right now. I don't think you can. Use a true myth / results. Dude, this is the JavaScript way. If you got a woe, use a library that makes it slightly less shitty but adds more complexity in code. Catch E, throw E. That's actually my favorite pattern. Catch E, throw E. It's my favorite. It's my favorite. Okay, I figured you didn't have anything to say in the vibe. Try, catch, throw, Jason broke. All right, anyways. All right, so we got a little geo response. Awesome, we got a little this. You know, I've never been the biggest fan of this right here. You know what I mean? I don't necessarily love this thing, but yeah, I'm not loving it. The JSON tags tell the JSON decoder how to map the JSON fields to the struct. Extra fields in the JSON response are ignored by default. I mean, I do like that. I do like that you have to state what you want, kind of like the old Rusties. Let's define another function that takes lat long and returns the weather. Okay, you hit them with the endpoint, you request. If there's an error, you got to do something. Get the body out. Read all the body. If there's an error, you're done. Else, return the string of the body. Pretty straightforward. All of this is pretty straightforward. Awesome. Latitude, longitude, bam, bam, bam. Routing. We're going to do a little Go forecast, get a little bit of Jin, get a couple gets, get the weather, get the city. This is awesome. I'm a little confusing why you'd have two different... Just confusing why you'd have two different paths to do the same thing, but whatever. Exact same thing. There we go. We're going to do the weather. We're going to get the city. We're going to get the lat long. Make sure that it actually exists. Get the weather. Make sure that it exists. Else return this. Perfect. Okay, straightforward. Bam, bam. Awesome. We're going to do a little bit of templating. Again, pretty straightforward. Here's some JSON. I can see right away that they're not using HTMX. All right, let's see. Let's extract the weather data. Okay, so it's going to do a little request, get the JSON Marshal, make sure we can have everything done correctly, return an error if we can't get the weather forecast. We're going to go through weather forecasts. Beautiful, beautiful. If there's an error doing any sort of parsing, it's going to just send them out, append them to the forecast, return them out. Okay, perfect. So this all seems pretty straightforward, right? Date handling is done with the built-in time package. The time package is actually really good in Go. The more I use it, the more I realize that it's pretty dang good. They've done a great job with it. To learn more about date handling, go check out this article. We've extended our route handler to render the HTML page. Again, they're not using what appears. This doesn't seem like HTMX, which just makes me want to vomit. Look at that. And there's tables without HTMX. What is this? What is this? What is this? Okay, anyways, you get the idea, right? It's going to render the this, blah, 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 blah. Do this, London. Beautiful. Okay, awesome. Database access. Okay, our server fetches the latitude and longitude for a given city with an external API on every single request. That's probably fine in the beginning, but eventually we might want to cache the results in a database to avoid unnecessary API calls. Let's go. Absolutely. Absolutely. First, let's see. First, we create a file named init squeal. Wow. All right, beautiful. There's a little squeal init. All right, there we go. Little serial, blah, 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 auto incrementing. Everything looks good. Do a little Docker, do a little database URL using Postgres and not Turo, weak, whatever. However, once we have our database, we need to add SquealX. SquealX is good times. SquealX, okay, connect to the database. Fantastic. Everything looks pretty good. Insert city, so anytime you look for a city, you just cache the results instead of re-looking it up. That seems perfectly fine. Get lat long, so now we're going to do a little database call. By the way, I do want to kind of show just like how nice this is. That you can just have, like, it's super easy to just use a database and Go. You can just pass around a database, you make queries, and things feel pretty good. It's pretty nice overall. There we go. This seems great. Awesome. Here we just pass the DB connection to getLatLong function. In real applications, we should decouple the database access from the API logic to make testing possible. We should also use an in-memory cache to avoid unnecessary database calls. You know what you should do? If you use just Terso and SquealLite, you know, you got yourself an on-file system, what's it called, database. All right. Do a little bit of weather check, a little bit of middleware, get some forecasts, get some stats, nice. Group routes together, get last cities. Okay, fantastic. We don't really need to look at this. Some basic auth. This is fantastic. So there's some auth kind of built into this. We get our little stats URL. I'm kind of just lightly going over the code because nobody actually goes over the code, right? Nobody actually looks at all the code completely. Pass around the database. I can't do that in the EU. Yeah, EU has some pretty strict laws about databases. Looks good enough to me. I like the idea. Didn't use HTMX. Pretty big failure, but everything else looking great. A Rust web service. Historically, Rust didn't have a good story for web services. There were a few frameworks, but they were quite low level. Only with the emergence of async await did the Rust web ecosystem really take off. Suddenly, it was possible to write highly performant web services without garbage collector and fearless concurrency. I gotta understand why people say fearless concurrency, because I still dread concurrency, okay? It's fearless async mutex. We will see how Rust compares to Go. Like, honestly, I get more sweaty and uncomfortable writing concurrency in Rust because I'm like everywhere. Just, it's so hard not to throw an arc mutex. Just toss one out here, toss one out there. It just happens. I know I'm just destroying the performance of just destroying it. Just murdering the performance. Just don't. Then it can't be fearless because I need send, sync, and static. Dog. All right. Which web framework? Okay, please. It's Actix or Axum. I believe that Axum came about because Actix, someone was upset about there being unsafe code, and the creator was like, I don't care. And then everybody was just like, get him! And so then they created Axum. I'm pretty sure that's the origin story of Axum versus Actix. Actix is a very popular web framework in the Rust community. It's based off the Actor model and uses async await under the hood. In a benchmark, it regularly shows up as one of the fastest web frameworks in the world. Axum, on the other hand, is a new web framework based on Tower, a library building async services. It quickly gained popularity. It is also based on async await. Nice. Both frameworks are very similar in terms of ergonomics and performance. They both support middleware and routing. By the way, one of the coolest things about Actix, and I think Axum has the same thing, any of your routes, you can just put arguments as part of your function, up to 9 arguments, I believe, and you just put an argument in there of a certain type, and the caller to that function based on the types will actually perform data transformations and get it out, right? So if you do like a form data from a form data post request and say literally form data this struct with Saturday, it will just do it all for you and hand it. It's like one of the most incredible aspects of developing in Rust. Absolutely. It is so good. Mwah. I will say that if you want to do Rust, a web framework, you really do need to have, or a Rust web service, you really just want a framework at this point. You can do it without a framework. It's just much harder. You can implement from request and pull any type of data. That is super cool. See, to me, that's like just super cool. I love that. I love that idea, right? I just absolutely love that idea. Both both frameworks are similar in terms of ergonomics and performance. They both support middleware. I wouldn't say they're similar. I would say that the Rust one is definitely superior. Oh, they're talking about between these two. Yeah, absolutely. Each of them would be a good choice for a web service, but we'll go with Axum because it ties nicely in with the rest of the ecosystem and has gotten a lot of attention recently. All right, routing, a little new forecast. There you go. Got a little Axum, got a little Quest. Ooh, Quest. Saturday, SquealX, and Tokyo! Everybody loves Tokyo. Okay, everybody loves Tokyo, except for that one person that writes those articles like don't use async or Rust, and Tokyo's inevitably mentioned in it. Let's create a little skeleton for a web service. Okay, create a router, have some routes, create a little sock adder, attach it to 127. What is this guy going to put in a Docker container? Do a little bind, do a little serve, little await, little unwrap. There we go. Seems pretty good. The main function is pretty straightforward. Yep, we don't even need to go over that. All right. Wait, do we have the other functions here? Oh, nice. There you go. Beautiful. We can curl all of them. Fantastic. Axum macros. Okay, before we move on, I'd like to mention that Axum has some rough edges. It will yell at you if you forget to make a handler function async. That doesn't feel like a rough edge. That feels nice. If you run into a handler is not implemented errors, the Axum macros create and annotate your handler with Axum macros debug handler, and this will give you much better error messages. Oh, that's cool. I didn't realize there's a debug one. That's pretty cool. Sock adder D's nuts? No, absolutely not. Absolutely not. Fetching the latitude and longitude. Let's rewrite the API. Okay, we get a little geosponse, a little Saturday, debug, clone, deserialize, classic. Really, that's the big three. Am I right? Am I right? That's like the big ones. You either got serialize or deserialize, debug, and clone. In comparison to Go, we don't tag to specific fields names. Instead, we use derive to serialize, an attribute from Saturday to automatically derive. I do love this way more. The fact that you do this and you don't have to annotate each field is so good. Okay, it's so good. All right, here we go. Fetch lat long. We're going to get a little city, references string. We're going to return a result with a dynamic error. For shame. Everybody knows you just use it anyhow, okay? All right, we're grabbing endpoint. We format the string in one go. We get the response. We get the endpoint. We await it. We get it as JSON. We get the geo response. We await that, and boom. So this is obviously way more terse, so let's go back up to the Go version. Fetch lat long. That's what I believe that's what they called it. Where's fetch lat long? Where's fetch lat long? I guess it doesn't quite have it here. Is it up higher? Where is it? I know we just saw it. I know we saw it. Is it? Oh, get lat long. So same thing, right? We do the encoding. We do a get. We check for errors. We read the body. We then decode. We check for errors. Then we respond. Now, if you go back down here, you can see all the exact same things in Rust. Where are we? Oh, I went too far. Everybody help. We make the request, pass in the endpoint, wait for it to be done, handle the error, get it into JSON, of type georesponse, wait for the response, the body to be read, handle the error. So it's a little bit more terse. I will say that Rust error handling is very, very nice, but one thing that you notice, there was no awaits in the Go code. There's no function coloring. It just is what it is, right? Let's see. Anyways, it's a little bit less verbose, yep, because the question mark handler effectively is if error equals null, does not equal nil, return error. That's pretty much all it is. So you can just do this, right? A response, results, get 0, cloned, okay, or no results found. Perfect. A few things happened. Do a little bit of that. Bada-da-bam, bada-bam. Okay, this looks pretty good. Match response. This is where Rust becomes more cumbersome. When you want to deal with your responses, you have to lift everything. Do you know what I mean? Like every single thing you do in Rust requires a lift operation. You have to match across enum results for everything. And that's the part that's really hard, I think, about Rust, or it gets really annoying. I find this to be a lift operation, this right here. So if you want to use response results, you have to check for some and none. And yeah, it's not bad, right? It's not bad, but monads, I know, but you have to do it for everything, every enum. And eventually you get into these situations where you just have so effing much pattern matching going on, but it's not like, it doesn't feel like useful pattern matching. That's why I'm so curious about Elixir, because Elixir, you can define functions based on pattern matching. So you could actually have one function defined 3 different times to handle the cases of each pattern and then react from there. And to me, that just seems like, a much better way to do things. Also, because the language is not garbage collected, you can't just like easily pull some of these things out and just lift out the value, and that's that. It sometimes becomes a bit more complicated. I just find myself having the if-elses are handled. They're just handled differently. You know, it is what it is. Advent of Elixir. No, we're going to do Advent of OCaml. Rust has an expression-based language, which means that we don't use the return. Oh, I use return because I'm not a psychopath, to return a value from a function. Instead, the last value of the function is returned. We can now update our weather function to use fetch lat long. Our first attempt. Beautiful. The program prints everything out. Look at that. Empty reply from server. Oh, pathetic. Why is it empty? The problem is we're using string for the type of city parameter. This type is not a valid extractor. We can use query. So this is the extractor thing that I was talking to you about earlier. Look at this right here. Okay, so there's 2 things going on here. First, a query with hash map string to string is saying the query parameters will be string to string, right? Obviously, you're not planning on having more than one value in any position. But second, look at this. They're doing... right there. They did pattern matching in the function to handle its one case. It's pretty cool. I mean, it's pretty cool. So then they just go in here and they get the value out. Bam, bam, bam. Obviously, these unwraps are just incredibly dirty. Don't be doing unwraps. I'm not even sure why you're doing unwraps at this point. Why not have something else? Because this is an option. This is a result, and so you're having a bit of an issue going on there. I think it would be a little bit better to return an option of string as opposed to unwrap, because that crap will just crash your entire system. All right, do one of those, get a little deserialized. Beautiful. Now we can have our little extractor. It just works. Look at that extractor. Look how good that looks. There we go. Cleaner. Look at this. Look at what it's doing, though. Did you see the difference? This is a hash map of string, so you have to grab something out of it. This is saying that the query parameter has to be minimum with a city equals string for this to be called. It's like pre-doing this. It's making it on types. So I do love this because this avoids this part right here. You don't have to do as much logic because your function's definition can do that effective if statement for you. It's very, very nice. Honestly, oh, by the way, the monad as a burrito thing, real talk, I have never understood the monad as a burrito analogy, okay? I think it's confusing for me, okay? Monads as Russian dolls is easier for me than monad as burrito. Okay, the burrito one is very confusing for me. I don't understand how it works. It's like a box that you can make into other boxes or other type shapes or other shapes in which can hold things in it. And then you have to lift out the value if there's a value at all. Sometimes you go to open your box and it's actually nothing. But sometimes you open your box and it's something. So you got to handle both cases, okay? Everybody knows that. Anyways, cleaner. A little bit more involved in the Go version, but there's more. But it's more type safe. You can imagine that we can add constraints to the struct to add validation. For example, we could require that a city is at least 3 characters long. Now about unwrap and weather function. Ideally, we would return an error if the city is not found. Okay. Awesome. Axiom, anything that implements into response can be returned from handlers. However, it is advisable to return a concrete type, as there are some caveats returning impl into response. Okay. In our case, result type. Okay, so we get this result string. Nice. Okay, good. It went to a result. That's what I was hoping to see. We do a match statement. We do an await. If there's a lat long, we return it as this beautiful string, else return the not found status code. Beautiful. 404. Awesome. All right, whether, fetch lat long, map error, status not found. A little confused about this map error right here. Little confused about it. We get this thing, bada bing, bada boom, looking good, right? Because this thing already returns this, so I don't know. Anyways, whatever. I don't know. I don't even know. There's another API. Oh, beautiful. Let's see. This is a variant that has an advantage that we the control flow is more linear. We handle the error right away and then continue with the happy path. On the other hand, it takes a while to get used to the combinator patterns until they become second nature. Fair. That's one of the biggest hurdles to learning Rust is that you have to to use Go. You can rely on your knowledge you have of programming from, say, TypeScript, from, say, C, from probably even Kotlin, D's nuts. You can rely on a lot of your abilities from other languages. Whereas Rust, to be effective at it, you have to really learn the Rust way of doing it. If you don't learn the Rust way of doing it, you look at other people's language or other people's code, and you're just like, what the hell's happening here? What is this? Right? You have to, you really do have to have the Rust way. I'm sure people are saying, well, what about the Haskell way? Maybe Haskell helps. I have no idea. Probably is my guess. OCaml would probably help as well. It's just different, but the same thing. This variant has some advantage. Oh, we already talked about that. Okay, there we go. We get our nice little cities. Perfect. Beautiful. I love that it's a 404 response code. We grab the weather, exact same thing. Make the URL, request, await, error, text, await, error, response. Beautiful. Beautiful. There we go. We get this, we get that, and we return it. This is cool, right? Can we all say that this does look nicer than Go? This is where I think Rust starts to shine, is when you start hitting this area, right? It's nice. This is nice. I like it. I like what I'm seeing. I like what I'm seeing quite a bit. This would work, but it would return the raw response object from the Open Mitio API. All right, so we're going to do a little bit of this. Let's go back to the Go definition. So we're going to do the same thing in Rust. Awesome. We're going to have a little hourly. Good. While we're at it, let's also define other structs we need. A little weather display, a little forecast. Do a little bit of that, a little bit of this, bam, look at that. Now it's going to come out as a weather response. Don't like the dyn error, though. Should definitely use this error or anyhow to get done with that. And so now we fetch lat long, fetch the weather, create the display, return the display. Beautiful. This is a great little piece of stuff right here, right? This is great stuff. I like all this. I actually like all this quite a bit. This right here, forecasts, I'd implement like an into, honestly. To me, an into would be really beautiful here to do this because you don't want to have to do like this all the way through, right? It just makes things really confusing. I'd much rather see it kind of a little bit slicker of a way, right? You have a weather display, you have a weather object, and just have a weather, like a try from or a from, depending, do you need a try? Looks like there's no tries in here. Just a from. It's nice. It just make it nice. Same with this thing. Another little from. Beautiful. Just makes things nice. All right, that's our start. Our handler now looks like this. Wonderful. Absolutely wonderful. There's let's see, that's already a little bit better. What's detracting is the map error boilerplate. We can remove that by introducing a custom error type. For instance, in the example of Axiom repository, or use anyhow. Let's go, anyhow mentioned, right? I just use anyhow, honestly. Anyhow. I'm a fan. C forever. Why are you guys loving C so much? Okay, I understand that C is great, but so is Rust. Nobody said C++, so you don't have to worry. You just don't have to. You don't have to worry anything. Pre-read. I did not pre-read this. Okay. Okay. All right. You don't have to fully understand this code. Suffice to say that it will set up error handling for the application. Yeah, I've never really used the. I've never actually just raw dogged an error. I've always just used anyhow or this error, but this looks pretty much just straightforward. Turn it into a status code or turn it into a response. Okay. You have a struct app error that is anyhow error. And then we can impl app error where into error from this self into bam, 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 bam. Good. All right. You don't have to fully understand this code. Most of the degenerates did not fully understand the code. Okay. Yo, you got to be quiet. Okay. I got things to do here. You need to shut up. Put it on do not disturb. All right. I want to see the database things. Ooh, templates. What's the template? Has anyone here played with templates in Rust? I'm curious about templates in Rust. Because it's either, like, I either really like Go, or I'm going back and forth between Go and Rust. And so I'm curious about a Rust template. I haven't tried Rust templates. I could really like them. So I would like to try it out. Honestly, this article is really good for the fact that they go from the fact they go from showing you lower level stuff with standard with showing you the alternative with libs. Yeah, that's nice. I like it too. Typed HTML is nice. Yeah. Don't click that. I'm not clicking nothing, okay? I ain't clicking nothing. All right. Let's see, templates. Let's go into templates, because this part I do want to know about. All right. Axiom doesn't come with a templating engine. We have to pick one ourselves. I usually either use Terra or Ascama with a slight preference for Ascama. Thanks, Obama. Thanks, Ascama. Because it supports compile time syntax checks. Oh, nice. And with that, you cannot accidentally introduce typos into the templates. Beautiful. That's a huge selling point to me. I still need to use Temple by Go. If you're not familiar with Temple with Go, let's see. I think I have a little thing up here. Where is it? Where are you? Oh, that's so bright. Why did I do this to myself? Oh, it's so bright. But look at this. Like, hold on. Oh, it's so bright. Like, hold on. Let's find one. Let's find a little. Look at this. For Go. That looks pretty cool, right? That looks pretty cool. I want to be able to do this. I want to be able to do that. I like that. I like what I'm seeing. So could I love it? I could love it. And it has compile time. It has compile time checks. So I like that. I like it. Anyways. All right, so let's see. Let's create a template directory and add weather HTML. Okay, we do a lot of that. Forecast for forecast and forecast, temperature data. Oh, interesting. So it's going to be like, is that handlebar style? Oh, my goodness. Oh, interesting. You have your templates directly tied to a singular struct. Yeah. I could get into that. I'm a little surprised you don't need to use pub right here. I'm a little surprised you don't need pub. You know what I mean? Weather display, new one of these. Weather display. Very cool. That is super cool. Very strange to see a form, then a doc type HTML, and then a form. I don't know what that is, but that's making me this like that's confusing me. I did slap some HTMX in there and boom, you got yourself a day. I don't like that. I don't know what that was. Something tells me that's a typo. But I actually think this is pretty cool. I like that. Maybe I could get back into Rust. Because I am just like a little bit better at Rust than Go. You know what I mean? Like, I'm just better at Rust. And the thing that pisses me off about Rust is that like I do like a good template, you know what I mean? Yeah, I think I've left the world where I think I'm completely out of the world where your template should be in your code. I think I'm fine saying I'm no longer that person. You know, like JSX. I still want to try Temple, though. Leptos, yeah, I love Leptos, but I just don't like the fundamental concept of template in code. You know what I mean? So I struggle with it. Honestly, I really do struggle with it. All right, database access, I'm very excited about this. Do a little database URL, create a connection, create a little bit of a pool, take that pool, toss it in here with a little bit of state. Let's go. Good state. Everyone likes a little bit of state. We have a little pool. We got a little bit of state. We got a little state PG pool. Yeah, baby. Yeah. Ooh, derive SquealX from row. That's nice. That's pretty nice. I'm going to talk to those Terso fellas about this. I want to see this. I want to see that. I would like to see more of this, right? Because I love a good derive macro, but also asking anyone to write their own proc macro is like asking them to, be circumcised as an adult. It's very painful. I can imagine it would hurt severely. Let's add the strangest comparison I've ever made in my lifetime. Let's add a function to fetch the latitude and longitudes from the database. It's the first thing I can think of, okay? All right, so we do a little bit of this. We do a little squeal query. We do a little bit of a bind. We do a little bit of fetch optional, and we await. Awesome. And look at that error handling right there. Perfect. Awesome. If lat equals lat, then we're good to go. Okay, cool. Okay. I like it. I like that very much. Else, we go and we fetch it. Then we insert into it. By the way, notice that, look at this. Can you believe that they're not using an ORM? Like, how are you ever supposed to actually program squeal without an ORM? It's impossible. All right, we do a little state, we do a little query, beautiful, a little bit of middleware. The last feature we're missing from our Go version is the stats endpoint. Okay, let's start with the basic auth. It took me a while to figure this out how to do. There are numerous authentication libraries for Axum, but very little information on how to do basic auth. I ended up writing a custom middleware that would check to see if the request has authorization header. If it does, check if that header contains a valid username and password. If it does, return unauthorized, or if it does, return an unauthorized response. Okay, header. Whoopsies. Here's the code. All right, so here's some authorization. Headers, do a little bit of headers. If there's some auth, starts with basic, credentials, this, that, all of that. Okay. Reject reasons. What is this thing? Is this some sort of implement from request for user? Okay, so we get a little user, do a little bit of header, get a reject response, bam. Okay. Cool. The from request parts is a trait that allows us to extract data from the request. There's also a from request which consumes the entire request body and thus only to be run once for handlers. In our case, we just need to read the authorization header from the request parts. Okay, that makes sense. We are authorized. The beauty is we can simply add a user type to any handler and it will extract the user from the request. That is like, okay, so this is where I get super impressed with Rust. Can you believe somebody wrote code to handle that? Hey, Chelstastic. Can you believe someone wrote that? That you go and you do this thing right here. You implement a trait and how to take a request and generate an object out of it. Then you just put that thing in a function and it just does magic. Just straight ass magic going on there. It's incredible. Axum is goated. Axum is, it's not cool. No, it's super cool. Obviously, the authentication thing, little strange, but the fact that you can do this with anything you want is super cool. All right, deployment, let's talk about that. Since both languages compile statically to a statically linked binary, they can be hosted on any virtual machine or virtual private server. That is amazing because it means that you can run your application natively on bare metal if you'd like. Another option is to use containers, which run your application in an isolated environment. They are very popular because they're easy to use and can be deployed virtually anywhere. For Golang, you can use a cloud provider that supports running static binary containers, or one of the more popular Google Cloud Run. Okay. There is, of course, containers to ship Rust. There's other options. One of them is ShuttleRS, of course. Who wrote this article? Why, it was ShuttleRS. That little rascal. ShuttleRS is the way that, let's see. The way it works is different to other services. You don't need to build a Docker image and push it to a registry. Instead, you just push your code to a Git repository, and Shuttle will build and run the binary for you. That's actually pretty cool. I do like these strong integrations with code repositories and deployment services. I like that. I like that. I don't know how to do canaries and how to do all that crap that goes along with it, but I like the idea of these kind of like one-to-one relationships. By the way, this song is insane that we're listening to. All right, we do a little shuttle runtime main. Do one of these ones. All right, all it takes to get started is a shuttle runtime main on your main function. Oh, wow. They have a little procedural macro to make this all work out. Install the, let's see, get started, install the shuttle CLI and dependencies. Cargo binstall. I don't know what binstall is. Cargo binstall. I don't know what binstall is. I know what install is, but binstall. All right. We do all the same stuff. We do all that. We set up our production staging. Okay, this is just going into how to do shuttle stuff. We're going to skip that. Skip the shuttle stuff. But it is pretty amazing. Pretty amazing. Okay, the Go version. The Go version is very simple and straightforward. We only need to add 2 dependencies, Jin and SquealX. Apart from that, everything else was provided by the standard library, the templating engine, the JSON parser, the datetime handling, etc. One thing I really do like about Go, Go is effectively a batteries included language. Even though I'm personally not a big fan of Go's templating engine and error handling mechanisms, I felt productive throughout the entire development process. We could have used an external templating library, but we didn't need to, as the built-in one was just fine for our use case. The Rust version, the Rust code is a little more involved. We needed to add a lot of dependencies to get the same functionality as in Go. For example, we needed to add a template engine, a JSON parser, a generalized parser called Serday as well. You need Serday JSON and Serday, right? A datetime library, a database driver, a web framework. This is by design. Rust standard library is very minimal and only provides the most basic building blocks. The idea is that you can pick and choose the dependencies you want that you need for your project. It helps the ecosystem evolve faster and allows for more experimentation with the core of the language, or while the core of the language is stable. Even though it took longer to get started, I enjoyed the process of working my way up to higher levels of abstraction. At no point did I feel like I was stuck with a suboptimal solution. With the proper abstraction in place, such as the question mark operator and the from request rate, the code felt easy to read without boilerplate, unnecessarily verbose error handling. This is actually a pretty fair article. This is shockingly a fair article. You know what I mean? I didn't think it was going to be that fair. This is actually a really good one. Go, easy to learn, fast, good for web services. Batteries included. We did a lot. A lot with just the standard library. For example, we didn't need to add templating engine or a separate auth library. Our only external dependencies were Jin and SquealX. Rust, fast, safe, evolving ecosystem for web services. The thing is that they're both really good. No batteries included. We had a lot of dependencies to get the same functionality. The final handler code was free from distracting error handling because we used our own error type and the question mark operator. This was nice. This makes for readable code at the cost of having to write additional adapter logic. The handlers are succinct, and there's a natural separation of concerns. That's the one thing about Rust, is that it makes the end product code look clean, but there's a lot that goes in behind the scenes on Rust that I think people discount. To make the end product look clean, you have to do a lot of stuff to make it clean. You have to just do a lot more. Rust lets you create a framework to improve your specific use case. Yeah. Traits and proc macros are the way. They are the way, but they're also like, the thing is, Swilker, we all depend on someone making those, as opposed to most of us don't make our own proc macros, right? The proc macros do all the heavy lifting. There's a lot of stuff going on in this code that you just simply don't see, and it like kind of tricks you for how simple everything is, when there was like a monumentous effort to get it to all work. If your end product is clean, is it more maintainable? Sort of. Hey, Lana Lux, thank you very much for that raid. I appreciate that. That's a lot of raids during this article. I'll say my thank yous after this. But the thing you're missing here that's kind of hidden is, remember, every time you want your own object, you do have all this boilerplate you have to generate, but then it allows for you to have this really clean interface in this one spot, which is kind of nice, because then you have this really nice separation of concerns. It just kind of works, and you have your little place that kind of has all the sucky code, right? There's always shitty code. Rust allows you to hide shitty code, I think, easier. It allows you to put it into like its own little basket, and it just does the shitty part for you, and then it comes out super clean at the end of the day. So is it better? Very well could be. For that. All right. So is Rust better than Go, or will Rust replace Go? Personally, I'm a big fan of Rust, and I think it's a great language for web services, but there are still a few rough edges and missing pieces in the ecosystem. Especially for a newcomer, the error messages when using Axum at times can be quite cryptic. For example, a common one is this error message, which occurs on routes not implemented in the handler. Yeah, those things can be confusing, seeing those. Once you know what you're looking at, then it's fine. Also, I mean, This is a pretty wild understatement. Type 1 in the chat if you know nothing about Rust. Okay, so we got a lot of ones in the chat. For those that aren't used to Rust, type 69 in the chat if this looks simple and straightforward to you. I said for those that aren't used to Rust, if this is simple and straightforward, type 69. Those are all lies. Every last one of them are lies because this is not simple or straightforward the first time you look at this. You guys are liars. I didn't realize there's that many liars in chat. Anyways, it's just something that I've noticed that it to get proficient in Rust is pretty monumentous amount of effort. And then once you get proficient, a lot of those things kind of float away and you can be pretty proficient on a good solid foundation of Rust. You don't have to become a wizard, but you do have to put a lot of effort into it to get good. Whereas Go, you can like literally know nothing about Go and you could build a web server, right? This is me knowing nothing about Go and we just built the web server, right? And we built this nice little application. Like, I really just don't know anything about Go. It's pretty straightforward. I still think I like Rust better, but still. Anyways. All right, in comparison to Go, the authorization part was more involved. In Go, we could just use middleware and be done with it. In Rust, we had to write our own middleware for the error type. Yeah, this whole middleware for the authorization and all that, I'm pretty skeptical about that. This is not necessarily a bad thing, but it requires some research in the Axum docs to find the right solution. Granted, basic auth is not a common use case for real-world applications, and there are plenty of advanced auth libraries to choose from. Exactly. There's plenty of just OAuth libraries that you can do that are so simple to use. Never roll your own auth. I think I could probably roll my own auth in Rust in like an afternoon. This whole don't roll your own auth crowd, it's kind of crazy. I mean, it's like OAuth. You like follow a link and set a return value of that link and store a little bit of information. It feels kind of crazy how much people are making it. Dude, does anybody remember the days when there was no OAuth 2? It's like you guys forgot about what happened before all these libraries happened. You know how shitty it was to develop anything ever? Like, at all? It was horrible. I don't know. Let's see. The mentioned issues are not deal breakers and mostly paper cuts related to specific crates. Core Rust has reached a point of stability and maturity that makes it suitable for production use. The ecosystem is evolving, but it's already a good place. On the other hand, I personally find the final Go code a little too verbose. The error handling is very explicit, but it also detracts from the actual business logic. In general, I found myself reaching for higher level abstractions in Go, like the aforementioned from request trait in Rust. The final Rust code feels more succinct. It felt like the Rust compiler was quietly guiding me towards a better design throughout the entire process. There's certainly a higher upfront cost in using Rust, but the ergonomics are great once you get over the initial scaffolding phase. All right, fair. Scaffolding can be a pain, though. You need to change something. You have a lot of scaffolding you have to take apart. I don't think one language is better than the other. It's a matter of taste and personal preference. The philosophies of the two languages are quite different. They both allow you to build fast, reliable web services. Should I use Rust or Go in 2023? If you're just starting out with a new project and you and your team could freely pick a language to use, you might be wondering which one to choose. It depends on your time frame for the project and your team's experience. If you're looking to get started quickly, Go might be the preferred choice. It offers a batteries-included development environment, which is great for web apps. However, don't underestimate the long-term benefits of Rust. Its rich type system paired with the awesome error handling mechanics and compile time checks can help you build apps which are not only fast, but robust and extensible. Fair. With regard to developer velocity, Shuttle, writer of article, can substantially lower the operational burden from Rust code in production. As we've seen, you don't need to write a Docker file to get started, and your code builds natively in the cloud, which allows for very fast deployment and iteration cycles. If you're looking for a long-term solution and willing to invest in Rust, I'd say it's a great choice. I invite you to compare both solutions and decide yourself which one is better. In any case, it was fun to build the same project in two different languages and look at the differences in idioms and ecosystem. Even if the end results are the same, we got there in quite different ways. Shuttle, RS, ad moment. I didn't get paid to read this. Shuttle RS, you should just send me a check. Or at least buy me a beer. How does that sound? Buy me a beer for this sweet ad you just got for freezy. Okay? Free ad. At least buy me a beer. $10 per stream. Yes, $10 per viewer. Can we get $10 per viewer? $10 per viewer. And then 20 cents per YouTube view. How does that sound? Sounds pretty good? I'll have my agent contact you. The name is the Primeagen. I did like this article quite a bit. I think they did a really good job breaking it down. I think they really showed the strengths and weaknesses of each language, and they did a good job representing Go. Because I think a lot of people that love Rust, they just go, Rust awesome, Go sucks, right? Like their brain, they have like React brain, except for it's also with Rust, and so they have Rust brain. This is good. I liked it. It was a good one. The shuttle guys are good. Yeah, they're good. That was a good article. Good job on you.